This is the second video in the series. If you have not watched the first video, please go to the playlist of my channel and check the playlist Linear Algebra. In that, you can see all the videos corresponding to the series. So, now this video is all about subspaces. So, let's see what is meant by a subspace. Subspace is nothing but it is a part of the vector space which independently stand as a vector space. So that's the informal meaning of a subspace. So formally, mathematically, we have this definition. So just going with the definition, before going with the definition, let's consider the R square. I told you R square is an important vector space that helps you to understand the concepts visually. So consider the plane R square. So now consider, you know that R square is a vector space over the field of reals. So now consider the x-axis. X-axis is a subspace of R square because x-axis is a subset of R square. It's a part of that R square. Now this x-axis acts as a vector space independently. So hence this becomes subspace. Say for example, W1 equal to set of all vectors on the x-axis are represented as x comma 0. X belongs to R, this is x-axis, it is subspace. When you add any two, like these kind of vectors, when you add any two vectors, it will be again in this x-axis, it won't go anywhere outside. If you scale a vector, either increase the length or decrease the length in same direction or opposite direction, so it will be on the x-axis, it won't go anywhere. Similarly, there is always 0. So on the x-axis, hence this becomes a subspace. So when you take y-axis, so again, y-axis is also a subspace of R square. That is because, same way, adding any two vectors on the y-axis will be a vector in the y-axis. It won't go anywhere. Scaling a vector on the y-axis, again it is on the y-axis. 0 is there on y-axis. Hence, it is a subspace. W3 you take any line passing through the origin. That becomes a subspace. Set of all points on the line which passes through the origin, y equal to mx or just y equal to x. So in that case, it becomes a subspace because you know that origin exists. So points x comma x, it becomes like x comma x. Okay, sum of these two x comma x, 1 comma 1 plus 2 comma 2, 3 comma 3. So that is again on that line. It won't go anywhere. So scaling a point vector on the line, again it is on the line. Hence, it becomes a subspace. Hence, it acts as in vector space independently. It becomes a subspace. W4, this 0, vector containing 0, it is always a subspace. And W5, R square, the given vector space itself. These are called as trivial subspace or improper subspaces. Now, W5, triangular matrices, set of all triangular matrices, subspace of M, N by N. So, square matrices, triangular matrix. Sum of any two triangular matrix, again a triangular matrix. 0 is a triangular matrix. Then scalar multiple of a triangular matrix, again a triangular matrix. Set of all symmetric matrices are also set of all symmetric matrices forms a subspace of a set of all matrices of order n. Sum of symmetric matrices is symmetric, and scalar multiple of a symmetric matrix is symmetric. 0 is always a symmetric matrix. Hence, it contains all those, it satisfies all those conditions. Hence, it becomes a subspace. Okay. Therefore, what is the formal definition of a subspace? A non-empty subset W of a vector space V over a field F is a subspace if W itself acts as a vector space over F. Okay, that means a vector space within a vector space. R square is a vector space. Within that, x-axis is a vector space. Y-axis is a vector space. Line passing through origin is a vector space. So otherwise, we can go with these conditions. We have to check, is 0 exist in that vector space? That is must. That condition is must. Is 0 exist in that subset? Similarly, W1 plus should be closed with respect to addition. It should be closed with respect to scalar multiplication. If these three conditions are satisfied, then we can say that it is a subspace of the given vector space. All other conditions like associativity and distributive, all other those conditions of vector space is not necessary because it is a subset of the given vector space. Okay, if those conditions are satisfying for the main vector space, as it is a subset, all those quantities are taken from those vector spaces only, vector space only, hence automatically it follows. But you have to make sure whether it is closed with respect to addition, or it is closed with respect to, is it closed with respect to addition, and is it closed with respect to scalar multiplication. That you have to make sure to say that it is a subspace, and zero identity element should exist. If that happens, then you can conclude it is a subspace. Rest all conditions will get automatically covered, as it is a subset of the given vector space. It holds for the entire vector space, so it will hold for the small few elements taken from that vector space. Now, which is not Aware subspace. Now, if you take W7, okay, I am giving, just naming W7, a set of all ordered triplets which are having the condition a greater than or equal to 0. First coordinate should be positive or equal to 0. This is not a subspace of R cube. This is because it is not closed with respect to scalar multiplication. Suppose if you take k equal to -1 or alpha equal to -1, alpha into that vector a comma b comma c is equal to -1 into a comma b comma c. This is equal to minus a comma minus b comma minus c. So this won't be there in this set. It is not closed with respect to scalar multiplication, as it is going to be negative here, because we want here positive quantities only, hence it is not a subspace. W8, a b c, a square plus b square plus c square less than or equal to 1, not a subspace of R cube. It contains all those vectors whose length is lesser than or equal to 1. We know that 1 0 0 belongs to this W8 because it is of unit length. 0 1 0 also belongs to this W8 because it is of unit length. This is nothing but magnitude of that vector. Okay, so these are of unit magnitude, but when you take their sum, when you take their sum vector addition, it becomes 1 comma 1 comma 0. This is not of unit magnitude. It is not less than or equal to 1. It is coming out to be 2 greater than or equal to 1. Hence, this condition is not satisfied. Hence, it is not a subspace. So, this is all about subspaces. In the next video, I'll come up with linear combination and linear span. Thank you for watching.